Welcome to Pauri. In this video we'll be covering GCSE Maths topics perfect for building a strong foundation at GCSE Maths. Whether you're new to GCSE Maths or just brushing up on the basics, this session is designed to help you gain confidence in topics like addition, subtraction, multiplication, division, fractions, and more. So before we get into the video, let's look at all the topics within GCSE Maths. So on screen you can see all of the topics covered in GCSE. If you can gain an understanding of each of these topics, you'll be able to do the exam with flying colours. So the top section in yellow is all the topics covered in Foundation GCSE Mathematics, and the topics in blue are the topics covered within Higher GCSE Mathematics, in addition to the topics in yellow above. The best way to understand these topics is work on each topic one by one. I could give you a GCSE exam paper and you might only be able to complete half of it. The best way to learn each topic is go away, understand the fundamentals of that topic, as well as certain topics that precede it if they're linked, such as to do algebraic fractions in grade 7. So down here, I first need to have a very strong foundation in fractions as well as algebra. So certain topics rely on a certain amount of knowledge within other topics from previous grades. As I've mentioned, this is a revision video for grade 1 mathematics and we'll be covering all of the topics mentioned in grade 1 here. What I'd say is, if you want to have a go at these worksheets and the material that we're going to go through, visit pauri.co.uk, so that's pauri.co.uk, and you can get the worksheets there. Once you've got the worksheets, have a go. If you've got any questions, then you can watch the videos and we'll go through all of the solutions. If not, you can pause the video as we go along. If you get stuck, watch the video to watch the solutions. So the topics covered in grade 1 GCSE Maths, this is the same for both Foundation and Higher Maths. We've got place value, so understanding the various place values, so single digits, tens, hundreds, etc. Also going into decimals, you get tenths, hundredths, etc. Addition and subtraction, how to add and minus numbers. Looking at multiplication, division, BIDMAS, what does BIDMAS stand for, what is BIDMAS, negative numbers, time, and all of these other topics on the right hand side. So if you are unfamiliar with any of these, have a go at the website, and once you've had a go at those, come back and watch the solutions. So let's go straight into the video. Place value. To recap, let's say we have a number 231. This has various place values. If we don't write anything, we've got 0.00 ... Another way to write that is just 231. So in the first digit, we've got the single digits. Next, we've got the tens, we've got hundreds, we've got thousands, we've got 10,000s, 100,000, million, etc. So if you have a number with a million, you'll have 6 zeros, so 1, 2, 3, 4, 5, 6. And it's sometimes easier to put commas. So we've got single digits, tens, hundreds, thousands, 10,000s, 100,000s, and then millions. The important thing with place value is to remember the other side as well. So if we go to this side, we get tenths, hundredths, thousandths, etc., etc. Question 1. Write down the value of 3 in the number 375. When we look at the number, we start from the right hand side and then work our way to the left. So we get single digits, tens, and then hundreds. So it is 300. Next question, write down the value of the 2 in the number 58.2. The 2 is the tenths. Next, write down a 5-digit number that has 7 as its thousandths digit. First digit is our single digits, tens, hundreds, thousands. This number over here will need to be a 7. And we need to write down a 5-digit number. So I'm going to add a few more numbers. And there's our 5-digit number. I'll put a comma as well. And 7 in its thousandths digit. Just note that the question said you can only use the 7-digit once. We've only used the 7-digit once in this number. The other thing to mention is look at the number of marks in the question at the bottom right of each slide. So you'll see how many marks each question is. If it's 1 mark, that usually means write down your answer straight away. We could have written 27,519. If there's 2 marks, then we'll need to give some sort of working out with our answer. And I'll give you more examples as we go through. Question 4, write down 2.3 million in figures. 2.3000. This is single digits, tens, hundreds, thousands, 10,000s, 100,000s, and then millions. The 7th digit here is the millions. 100,000s, 10,000s, thousands, hundreds, tens, and single digits. So our final answer would just be 2.3 million or 2300000. The commas help quite a lot here. Next question, write down the following number in order of size. Start with the smallest number. With these questions, it can get quite tricky if you are not too confident with the use of decimals. So I'm going to draw a number line to help us. If I have a number such as 2.8, 2.8 is going to be somewhere over here. 0.28 is going to be somewhere over here. 28 will be much more further up. 0.028 is even smaller. It's probably going to be even less than that. And 0.82 is closer to 1. Let's put all of that in order. Smallest number is 0.028, which was my number over here. Next one was 0.28. Next one was 0.82. So those three numbers cover these three over here. Next we've got 2.8, which covers this one. And we've got 28, which covers the last one that I mentioned. Question 6, write down 6324 correct to the nearest thousand. So here we're doing a bit of rounding. We want to look at the digits. Which one is the thousands? So single, tens, hundreds, and thousands. We want to round this number to the nearest thousand. Is the next number 5 or above? No, it's not. So this number, 6,324, is closer to 6,000. If the question said 6,514, the next number here after the 6 is 5 or above. That means the number is closer to 7,000. Even if you get a number such as 6,500, because this is 5 or above, we always round up to 7,000. If you get a different question which said 6,499, as the hundreds digit is 5 less than 5, we round down. So this number is closer to 6,000. We've rounded this number to the nearest thousand. Think about what you're rounding to the nearest which number. Hundreds, thousands, whatever it might be. This was a exam question, so down here on the right hand side I've written a reference to the exam. As we go through, we'll be looking at exam questions as well as questions with exam style technique. Write down the following number in order of size, starting with the smallest number. Again, we'll draw a number line to make it a little bit easier. I can see all of my numbers are within 0 and 1. Draw a number line here. The first one, 0.078, that is going to be less than 0.1. That's going to be over here. 0.78 is much more further up. 0.87 is even bigger than that. And 0.708 is going to be less than the second number, because this is a 0 in the hundredths column. That is going to be this number over here. Let's put that all in order. 0.078. 0.708, 0.78, and 0.87. At the start, you can draw a number line if it does help you. Once you get more confident with these questions, you can do it without a number line. Again, this is 1 mark in a real exam question. Next question, write down a 6-digit number. So let's think about digits. 1, 2, 3, 4, 5, 6. That has a 4 in its thousands. So I know this number here is the thousands place value. I need a 4 there, and it says you can only use the 4-digit once, so I'm going to add other numbers elsewhere. This is fine as an example of an answer. You can also do something like this if you wanted to, because we've answered the question. We've only got a 4 once here, and all of the other digits are different numbers, so that is fine as a solution. That's 1 mark. So hopefully you've understood place value. If you haven't, go over the questions again, look over the topic, and retry the questions in this tutorial. Let's move on to the next topic. Next topic is addition and subtraction. We'll do a high-level overview before we move on to actually trying some questions. So let's try an easy example, 13 plus 48. What we do when we add up numbers, we put it in this format. We've put one number above the other number, and we're going to start with the right hand side. We're going to add the 3 and the 8 first, and then we're going to add the 1 and the 4. A common mistake students make is they forget that this 1 relates to the tens column. This 4 relates to the tens column as well. So this 1 is a 10 and this 4 is a 40. And we'll come on to that as we do the question. 3 plus 8 is 11. So 11 doesn't fit. I can't put 11 like this. What I need to do is put a 1 in the single digits, and I need to put a 1 up here, which relates to a 1 in the tens column. 4 plus 1 plus 1. 4 plus 1 is 5, plus 1 is 6. My answer is 61. And there's an easy way of checking that as well. Let's say we split up 13 into 10 and 3. So 48 plus 10 plus 3. 48 plus 10 is 58 plus 3. 58 plus 3 is 61. Let's try a question with subtraction. Same sort of setup. 72 minus 14. And just before we do that, we'll do an easier question and we'll come on to that one. Again, we start with the right hand side. 1 minus 0 is 1. We start with the top number first and then we move down to the bottom number as we do it. Never do it the other way around. And then 8 minus 1 is 7. So answer here is 71. Let's try that other question. Again, starting with the right hand side, top number. 2 minus 4 we can't do. And because I've got a 7 here in the tens digit, I can actually borrow 1. Instead of having 70, I can change this to 60. And I'll put the 1 or the 10 with the 2. So 10 plus 2 is 12. Now I can do 12 minus 4, which is 8. And then 6 minus 1, which is 5. So my answer here is 58. So let's have a go at question 1. Work out 364 plus 29. Let's get the setup correct first. So once we've written it down, give yourself ample space. Start with the right hand side, top right. 4 plus 9 is 13. So I've got 3 in my single digits and 1 in my tens digits column. 6 plus 2 is 8 plus 1, which is 9. And then 3 plus nothing is just 3. My answer is 393. So where I got the middle column, 6 plus 2 is 8 plus 1, the one up here from when we did 4 plus 9. 4 plus 9 was 13, so 3 in the single digits, 1 in the tens column. Equivalent to saying 60 plus 20 plus 10, or 6 plus 2 plus 1, which is 9. Or 9 in the tens digit column. Next question, question 2. Work out 1267 plus 343. One of the really important thing with these questions is make sure you're lining the numbers up. The 7 goes with the 3, which are single digits. 6 goes with the 4, which is the tens digit. 2 with the 3, and then the 1. 7 plus 3 is 10. 6 plus 4 is 10, plus 1, 11. 2 plus 3 is 5, plus 1, 6. And then 1 is left. 1610. We've got 2 marks for this question. So 1 mark goes for your final answer and 1 mark goes for your working out. In an exam, if you just wrote down the final answer without showing your working out, you'd only get 1 mark. So it's really important you look at the marks. And that's why we've got this section down here, because we want you to see the marks in the question and get used to looking at that and making sure you've got the appropriate amount of working out. Question 3, subtraction. 1, 2, 4, 8. Minus 3, 6, 4. 8 minus 4 is 4. 4 minus 6 we can't do, so we need to borrow from the place value above. 14 minus 6 is 8. 1 minus 3 we can't do, so again we need to borrow from the place value above. 11 minus 3 is 8. Final answer is 884. Next question, 2855 minus 1354. 5 minus 4 is 1. 5 minus 5 is 0. 8 minus 3 is 5. 2 minus 1 is 1. 2 marks. 1 mark for the answer. 1 mark for your working out. Question 5. Work out 23 plus 12.6. So this is using a bit of place value now, because you need to have an understanding of how to set up the question or how to write it down. With this, the method is still the same, but we need to align these decimal places. If nothing's written, it's 0.0 over here. And once we've got that layout, it's the same. We start from the top right hand side and then we work our way to the left. 0 plus 6 is 6. Add the decimal place. 3 plus 2 is 5. 2 plus 1 is 3. Final answer is 35.6. Another question, 23 minus 14.6. Make sure the setup is correct. Decimal places align with each other and all the place values align with each other as well. 0 minus 6 we can't do, so we need to borrow from the place value above. 10 minus 6 is 4. Add your decimal point. 2 minus 4 we can't do. borrow from the next place value. 12 minus 4 is 8. 1 minus 1 is nothing. So my final answer is 8.4. Next topic is multiplication and division. So we'll go through some examples before we move on to the questions. 23 times 12. What we're going to do is work with the 2 first. We're going to do 2 times 23, and then we're going to do 1 times 23. So 2 times 23, we're going to start with the right hand side and then work our way to the left. So 2 times 3 is 6, and then 2 times 2 is 4. I've done the 2. The next thing is to move on to the 1. The only thing to remember with the 1 is this isn't an ordinary one. This is part of the tens column. Instead of 1 times 3, this is more like saying 10 times 3 and 10 times 2. Because it's in the tens column, I'm going to add a 0 here, so I know that I've already done the 10. Now that I've added the 0, it's now going to be 1 times 3 and 1 times 2. 1 times 3 is 3, 1 times 2 is 2, and we're going to add up these numbers. Just to recap, we did 2 times 23, or 2 times 3 and 2 times 2, which is 46. And then we did 10 times 23. So remember, this is like a 0. We split the 12 into a 10 and a 2. Instead of remembering that it's a 10 times 3 and 10 times 2, we added a 0 here. And then we did 1 times 3, and then we did 1 times 2. Add them up. 6 plus 0 is 6. 4 plus 3 is 7. And we've got 2. Final answer, 276. So moving on to division, we'll do a question 4 divided by 30. I'm going to add a few more zeros in case we need it. So this is the opposite. So we start from the left hand side and then work our way to the right hand side. Can we divide 4 into 3? We can't. So if we do our 4 times tables, 4, 8, 12, we don't get to 3. That comes before our first multiple, which is 4. So we move on. We add another digit to it. Essentially, this is like a 0, but I'm not going to write that. 4 times 30, I do my 4 times tables. 4, 8, 12, 16, 20, 24, 28. That goes 7 times. And I've got a remainder of 2. So that goes with the next place value. Same as before, line up your decimals. You add a decimal here as well. 4 times 20 is 5. And that's it. I've used up all of my numbers. If you have other numbers, so let's say you did that and you've got more remainders, you can end up with recurring numbers where you'll just keep on getting the same scenario. So let's say you've got a recurring number of 0.3333, etc. Another way to write that is 0.3 recurring. And the way we write recurring is add a dot on top of the 3. So you should be ready to try the questions. So let's have a go. Question 1. Work out 132 times 14. Give yourself lots of space. Line up your place values. You're going to do 4 times 132 and then 10 times 132. 4 times 2 is 8. 4 times 3 is 12. 4 times 1 is 4 plus 1 is 5. What you can do is get rid of this 1 that was a remainder at the top because we don't need that anymore. Add a 0 because we're looking at the tens column now, which is over here. 1 times 2 is 2. 1 times 3 is 3. And 1 times 1 is 1. Add up these numbers right to left. 8 plus 0 is 8. 2 plus 2 is 4. 5 plus 3 is 8. And we get a 1. So final answer, 1,848. 2 marks for this question, 1 mark for your solution, and 1 mark for your working out. So that includes both of these parts. Question 2, 312 times 15. You can see I'm spacing out my numbers quite a lot just to make it more easy to see visually. Give yourself lots of space on the page. 2 times 5, so we're going to do 5 times 312 and then 10 times 312. 5 times 2 is 10. 5 times 1 is 5 plus 1 is 6. 5 times 3 is 15. Again, I'm making the mistake of not lining them up. Even the lines here, I'm looking at the hundreds column, that should all be lining up together. And the same with the tens and the single digits. Add a 0 because we're now looking at the tens column. 1 times 2 is 2. 1 times 1 is 1. 1 times 3 is 3. Add them up right to left. 0 plus 0 is 0. 6 plus 2 is 8. 5 plus 1 is 6. And 1 plus 3 is 4. Final answer, 4,682 marks. So let's get the format of the question right before we start. 324 divided by 6. Add a few zeros in case we need them. 6 goes into 3. How many times? It doesn't go. So move on to the next digit. 6 into 32. That goes 5 times with a remainder of 2. 6, 12, 18, 24, 30. If I go to the next multiple, that's 36, which is above 32, so I need to go back to the fifth multiple, which is 30. Remainder 2, because our number is 32. How many 6's into 24? That goes 4 times. Final answer is 54. Question 4, a bit more tricky now. 283.2 divided by 8. And what we can do with this fraction before we do our division method is times top and bottom by 10. And you'll see that makes it a lot easier for us. And we're allowed to do this because if we have a fraction 10 over 10 and we're timesing something else by 10 over 10, anything divided by itself is the same as just saying 1. So let's think about that for a second. If we've got 10 cake pieces and we're sharing them between 10 people, that means each person gets 1 piece of cake. So that means we're not changing this question that we've got. We're keeping it the same. We are only changing how the numbers are presented. Our top number becomes 2,832. Our bottom number becomes 80. Let's do our division method on that. So 2832.00, add a few zeros. Don't get too worried, but we're going to do our 80 times tables, so whatever number's on the outside. How many 80s into 2? It doesn't go. How many 80s into 28? It doesn't go. How many 80s into 283? 283. So let's try it. 80, 160, 240. If I go above that, I'll get more than 283. So that goes 3 times. So we got up to 240. Our remainder is 43. So again, we do the same, or 80 times tables. In my head, to be honest with you, I do 8 times tables and then I add a 0. So we want to get up to 432. So I'll show you what I mean. 8, 16, 24, 32, 40. If I go ahead, I'll get to 48, which is above 43. This goes 5 times. So 80 times 5 is 400. I'm left with a remainder of 32. Add a decimal point. How many 80s into 320? 80, 160, 240, 320. That goes 4 times. My final answer is 35.4. The other way of doing the question is doing it without timesing top and bottom by 10. So if we just did 8, how many 8s go into 283.2? This also works as well. So I'm just giving you different methods to give you different ideas of how to do the question. Generally, this would be the preferred method, but we'll see how the method above helps in other questions coming up. How many 8s go into 2? It doesn't go. How many 8s into 28? 8, 16, 24. That goes 3 times, the remainder 4. How many 8s into 43? That goes 5 times, remainder 3. How many 8s into 32? That goes 4 times. Final answer again is 35.4. So you can see that method is a lot quicker than what we've done above. But what we've done above will help when it comes to fractions. 31.25 times 3. So remember this is 0.00. I can ignore the 00s for now, and I'll get rid of that decimal point. So it's going to be 3 times each of these numbers, starting from the right hand side, moving to the left. 3 times 5 is 15. So follow your place value, that goes down there. Remainder 1. 3 times 2 is 6, plus 1 is 7. 3 plus 1 is 3. 3 times 3 is 9. Final answer is 93.75. Next question, 31.2 divided by 0.6. So this is what I mentioned previously, where we can times fractions by the same number as long as we multiply by the same number, top and bottom. 31.2 times 10, 312. 0.6 times 10 is 6. We can now do long division on that because that number is a lot easier to deal with than 31.2 and 0.6. There'll be certain scenarios where this method's more helpful than just trying to do long division of 0.6 and 31.2. This is one of those examples. How many 6's go into 3? Doesn't go. How many 6's into 31? Goes 5 times, remainder 1. So I'll do my multiples to show you. 6, 12, 18, 24, 30. That goes 5 times. And 6 times 5 is 30, but our number over here is 31, so we have a remainder of 1. How many 6's into 12? That goes twice. My answer is 52. Next question we can see is an exam question from June 2019, and it's 2 marks. So 74 times 58. Notice that this is in the foundation paper over here, paper 1. So starting from the right hand side, 8 times 4, 8, 16, 24, 32, got 3 up there. 8 times 7, so again, 8, 16, 24, 32, 40, 48, 56, add 3, 59. Add a 0 because this 5 is in the tens digits. I'm going to cross out that 3 at the top, get rid of that so it doesn't confuse me. 5 times 4 is 20, got a remainder of 2. 5 times 7 is 35 plus 2, which is 37. Add these numbers up, starting from the right hand side. 2 plus 0 is 2, 9 plus 0 is 9, 5 plus 7, 12, remainder 1. 1 plus 3 is 4. Final answer, 4,292. Another question from an exam paper, June 2017. This time it's from a higher paper, so paper 1 of the higher paper. Question 3. 54.6 times 4.3. To make that easier for us, what I'm going to do is if I times this number by 10 and times this number by 10, I'm going to get whole numbers. So this will become 546 because I've times by 10. This will become 43 because I've times by 10. If I times by 10 here and times by 10 there, 10 times 10 is 100. To get back to what I had as my original question, if I'm timesing by 100 at the top, I also need to divide by 100 to get back to what the question was originally. So on the left hand side, if I call this 1, and 1 is just going to be this calculation, 546 times 43. Make it easy for yourself. Write down what you're doing and show the examiner what you're doing to make it easy to follow for you and for them. 3 times 6 is 18, remainder 1. 3 times 4 is 12 plus 1 is 13. 3 times 5 is 15 plus 1, 16. Next, moving on to the 40 or the 4, add a 0. 4 times 6, let's get rid of those 1s as well before we carry on. 4 times 6 is 24, remainder 2. 4 times 4 is 16 plus 2, 18. 4 times 5 is 20 plus 1, 21. Add them up. 8 plus 0 is 8. 3 plus 4 is 7. 6 plus 8 is 14. Got 1 up there. 1 plus 1 is 2 plus 1 is 3. And we've got a 2. And remember, after each digit you can add a comma. So the final answer here for this first part is 23,478. So to answer this question, I need to do 23,478 divided by 100. If my decimal place is there, I need to move this 2 times. Because I've got 2 zeros, I need to move it 2 times to the left. So this number is going to get 2 times. It's going to get smaller by moving the decimal place twice. So my final answer is 234.78. Next topic is BIDMAS. So let's write down what BIDMAS stands for. BIDMAS. BIDMAS. B is for brackets, and I'll explain what all of this means in a minute. I is for indices. D is for division. M is for multiplication. Hopefully you know what the last two are. A is for addition, and S is for subtraction. Okay, this tells us the order of operations to do something. So let's say we've got a question where we've got 3 times 1 plus 4 divided by 2, and let's say we have another set of brackets squared. What do? Do I do 3 times all of this? It gets a bit tricky. You need to think about what to do first and in which order. So BIDMAS tells us which order that we need to do our operations in. Brackets always go first, so we would do these brackets. What's inside the brackets? 1 plus 4 is 5, and then we've got 5 divided by 2, which is 5 over 2. Once we've done all the brackets, we would square it, and then we times by 3. So we'd square it and then times by 3. This will be a lot easier when we go through the questions. So let's go through one now. 5 times 6 minus 12. Think about BIDMAS. What comes first, multiplication or subtraction? BIDMAS, M, it comes before S. 5 times 6 comes first, so that's 30 minus 12. 30 minus 12 is 18. A few points on notation. Throughout all of your GCSE, as well as any maths you do after GCSE, work downwards. So have your equals below each other every single time. I see some students doing this, so avoid this. You don't want to be writing equals on multiple lines. You want 1 equals per line. That makes it nice and easy to follow along with what you're doing. The other thing, as I mentioned with multiplication and division, is get your place values correct. You want everything lining up for those types of questions. For this, focus on your equals. You want your equals to be in the right place. Nice, easy, 1 mark. Question 2, 7 times 7 plus 31. What comes first? You've got two operations, multiplication and addition. M comes before A, so BIDMAS, MA. So 7 times 7, 49 plus 31. We can do that in our head. We don't need to do our big calculation that we did before. If you're not sure, break it up. You could do 49 plus 30 plus 1. You could also do 49 plus 1 plus 30. Or you could keep 31 and break up the 40 and the 9. 49 plus 1 is 50. 50 plus 30 is 80. Next question, 16 plus 5 squared. Indices. So this is a power, if you haven't seen it before. 5 squared basically means 5 times 5. 5 cubed means 5 times 5 times 5. And hopefully you see the pattern here. 5 to the power 4 means 5 times 5 times 5 times 5, etc, etc. 5 to the power of 1, instead of you having 5 twice like you did up here, you've only got 5 once. And a general rule with powers or indices is anything to the power of 0 is 1. So it's something you just need to remember. 16 stays the same, so when we write the question, we always start from the left-hand side and then work our way to the right-hand side. 16 plus 5 times 5 is 25. Add them up. Again, what I'm doing in my head is 16 plus 20 plus 5, or you can think of it whichever way you want. 16 plus 20 is 36, plus 1 is 41. Next question, 1 plus 7 squared. BIDMAS, do brackets first. Everything inside the bracket first. 1 plus 7 is 8 squared. 8 times 8 is 64. Easy, 1 mark. Next, write down your question, 80 minus 7 plus 2 squared. Do your brackets first. So you've got 3 operations here. You've got brackets, subtraction, and indices. So brackets go first. 80 minus 7 plus 2 is 9 squared. And I'm going to get rid of the bracket now because we've done it. I don't need to write it down again. 80 minus, do indices next. 9 times 9 is 81. 80 minus 81 is minus 1. Just remember on your number line you've got 0, 1, 2, 3, etc, etc. But if you go the other way, you get minus 1, minus 2, minus 3, etc. So 80 minus 81. 81 is 1 more than 80, and if we're subtracting that from 80, you get to minus 1, which is over here. So it'll be this point. 6 times 4 minus 2 to the power of 0. Think about your operations. You've got 3 operations, multiplication, subtraction, and indices. Which one comes first? The one that comes first is indices. So let's do indices first. 6 times 4, anything to the power of 0 is 1. 6 times 4 is 24, minus 1. Let's do all the steps. 24 minus 1 is 23. Next question, 10 times 3 plus 5. Do your brackets first. 3 plus 5 is 8. Do multiplication. 10 times 8 is 80. This is an exam question. 1 mark from foundation paper. Nice easy mark to obtain. Moving on to a worded question. Jenny is asked to find the value of 12 minus 2. So let's do it. What I'd recommend with these questions is do the question or do as much as you can as you read through it. Don't read the whole thing. You can always work stuff out as you go along. 2 operations, you've got subtraction and multiplication. Multiplication comes first. 2 times 4 is 8. 12 minus 8 is 4. Okay, here is her working. 12 minus 2 times 4, which is the question. It looks like she has done 12 minus 2, and that's how she's got 10. So she has done the subtraction first. Jenny's answer is wrong. Yes. Explain what Jenny has done wrong. So Jenny hasn't used BIDMAS. And the key points that you want to write when writing your worded answer is multiplication before subtraction. So when we look at BIDMAS, multiplication comes before subtraction. So we need to do 2 times 4 in the question before we look at the 12. 1 mark. With these questions, make sure you answer what the question is asking you to do. The question says explain. So So you need to explain what Jenny has done wrong. It's no good you writing what I did earlier, although this helps us to understand what she has done wrong. But this won't get you the mark that you're looking for. An explanation will get you the mark you're looking for. So make sure you're actually answering the question. Negative numbers. Let's go back to our number line. So you've got 0, 1, 2, 3, etc. You've got -1, -2, etc. If I've got a question such as 1 minus 3, I'm starting at 1, which is over here, and I'm going back 3. So 1, 2, 3. My answer is -2, -2. And we can see that on the number line. If we've got -2 plus 4, again, we can see we're starting at -2. We're going to go to the right hand side 4 times. So 2, 3, and 4. That takes us up to 2. So try and think of the number line to begin with if you're not too confident with negative numbers, or if you're getting a little bit confused. Draw a number line and see which way you're going. If you've got -80 plus 12, think of a number line. Maybe don't draw it from 0 all the way to -80, that won't be helpful, but imagine you've got -80. You know, as you go to the right hand side, this number will get smaller until it gets all the way to 0, as we have above. And if we go to the left hand side, the numbers will get bigger. So we're starting here at -80 and we're going plus. So which way is plus on the number line? It's to the right hand side. So the number that I'm going to have as my answer will be, because I'm going this way, it's going to be smaller than 80. So -80 plus 12 is going to be -68. So let's have a go at the questions. Question 1, 8 minus 13. Think of your number line. We're going to the left hand side. 8 minus 13 is -5. 1 mark. -6 plus 9. Think about your number line. We're starting at -6. We're going plus 9, which is to the right hand side, plus. So the numbers will get smaller until you get to 0. Then they'll become positive. So -6 plus 9 is 3. Next question. -4 minus 4. We're starting at -4 on the number line. Remember the numbers next to it. -3 and -5. We're going 4 to the left hand side because we're going minus. So go 4, you'll end up at -8. Question 4, -6 plus and -2. So quick recap, if you've got multiple signs, what happens? This is just something you need to remember. Plus and a plus is a plus. A minus and a minus is a plus. And anything else is going to be a minus. So plus and a minus is a minus. Minus and a plus is a minus. And you can apply that to 3 signs together. If you get minus, 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 minus is a plus, and then a plus and a minus is a minus. So you can work these out and make them a bit more complicated and practice them. So let's simplify the question. -6 plus and a minus is a minus. -6 minus 2 is -8. 10 minus -16. Minus and a minus is a plus. 10 plus 16 is 26. Here are 4 numbers. Write one of these numbers in each box to make a correct calculation. So we want to get to +5. We can do 9 minus 4. That will get us to 5. And we can check that if you're not sure. 9 plus -4. Plus and a minus is a minus. 9 minus 4 is 5. Okay, next question. Write the following numbers in order of size, starting with the smallest number. Think of your number line. Zeros here. Positive numbers will be to the right hand side, so 1, 2, and negative numbers will be on your left hand side. Looking at the most negative number, that's -6. As we do these, I'm going to cross them off so I remember that I've done that number. -5 is next, 0 is next, 6, and then 12. This was an exam paper question. Question 1, Foundation, June 2018, 1 mark. Again, another exam paper question. Question 2 in the June 2019 paper. Write the following numbers in order of size. Start with the smallest number. So which number is the most negative? -3. Cross that out. Next is -1. Then we have 0. Then we have 2. And then we have 4. Next topic is time. So let's think about conversions of time. I think that's the best place to start. So 1 hour, you need to remember, is 60 minutes. And 1 minute, or min for short, is the same as 60 seconds. Think about your conversion when you do these sorts of questions. So if you've got 80 minutes and you're trying to convert that to hours, that's the same as saying 60 minutes plus 20 minutes. And the reason why I've written 60 minutes is because I know that 60 minutes is 1 hour. If I'm trying to convert into hours, the easiest way to do it is to split up the number. 60 minutes is 1 hour, and 1 hour, and what's left, 20 minutes. 1 hour, 20 minutes. Okay, so let's try some questions. Question 1. Change 90 minutes into hours. So 90 we know is 60 minutes plus 30 minutes. 30 minutes is the same as saying half an hour. 60 is the same as saying 1 hour. So you've got 1 hour and a half hours. The other way to do it, if you're not sure about this, is dividing by 60. So if you divide by 60, you're changing minutes into hours. And you'll see that 10 divided by 10, we'll get rid of the zeros. That's another way to think of it. How many 6s go into 9? You can then do your division method we've done previously. Well, I know my answer here is 1.5. And write down your units, hours. Next, change 5 hours into minutes. So you can do the opposite. So you can times by 60. The method I'm using, if you're not sure, is hours is the same as minutes times 60. And you can rearrange this formula. When you've done algebra, this will make a bit more sense, but we can change this to minutes equals hours over 60. Okay, so 5 times 60 is 300. 5 hours is the same as saying 300 minutes. Change 75 minutes into hours. Because this is in minutes, I need to divide by 60. How many 5s go into both 60 and 75? Because I know 5 goes into both these numbers. 5 goes into 60 12 times. 5 goes into 75 15 times. We can simplify that further. 3 goes into both. How many 3s into 12? 4 times. How many 3s into 15? 5 times. My answer is 5 over 4 hours. And we can leave our answer as a fraction. You can convert it to decimal if you like. The way we convert it into decimal is by using our division method, otherwise known as short division. So how many 4s into 5 goes once, remainder of 1. How many 4s into 10? It goes twice, remainder of 2. How many 4s into 20 goes 5 times. So another way to write our answer is 1.25 hours. Depends on what the question asks you. Sometimes it might say give your answer as a decimal. If it doesn't say, I'm sure you'll get full marks for leaving it as a fraction. Change 2.5 hours into minutes, so 2.5 times 60. That's the same as saying 2 times 60 and a half times 60. So I'm splitting up the 2.5. Hopefully this is easier for you. 2 times 60 is 120. A half times 60 is 30. 120 plus 30 is 150. Units is minutes. 1 mark. So work out the difference. Keyword here is difference. Before I even read any more, difference means minus in maths. So work out the difference. It means minus the numbers in minutes between 30. So 30 is my first number. Difference means minus. I need to convert them to the same thing before I can put them together. 1 and 1/5 hours. That's the same as saying in minutes. We're going to times that by 60. And I'll show you what to do. This is called a mixed fraction, and the way we make it into a top-heavy or improper fraction is we do 5 times 1, which is 5, plus 1, which is 6, 6 over 5, and I'm sure we'll have some more practice further on of converting mixed into improper. If nothing's written, this is all divided by 1, and now we can also do a cross simplification because we've got numbers at the top and we've got numbers at the bottom. If we can simplify, usually we can simplify them down like this. So how many 5s into 5? 1. How many 5s into 60? 12 times. 6 times 12 is 72. Anything divided by 1 is itself. So whatever's on the top line, you can rewrite it without saying over 1. Another way to think of it is if you've got 72 pieces of cake and you split it between one person, how much does each person get? That one person gets the 72 pieces of cake. 2 marks here. Next question, a movie starts at 6:50 p.m. So just be a bit careful with these sorts of questions. And the movie lasts 83 minutes. So instead of writing 83, let's think about how I can split it up to make it easy for me. I need to have 83 as my total though. I know how many minutes does it take for me to go from 6:50 to the next hour. If I add 10 minutes to that, that'll take me up to 7 o'clock. So if I do, instead of 83, I've used up 10, so I've got 73. 60 is another hour. That is 70 minutes out of the 83 I've used. So what's left? I've got 13 minutes. So in total, started at 6:50, plus 10 is 7 o'clock. Next to these, if you want to, you can also put minutes. 7 o'clock plus 60 is 8 o'clock, and then 8:13 is the time the movie finishes, 8:13 p.m. So don't forget about your units. Follow what the question's asking you and what it says. Ruth got to the library at 10:30 a.m. Again, I'm going to leave a gap because it'll be easy for me. She stayed at the library for 50 minutes. If I add 30 minutes, that takes me up to the next hour. What's left? 20 minutes. 10:30 plus 30 minutes is 11 o'clock. 11 plus 20 is 11:20. She leaves the library, and that's a.m. Let's carry on reading the question. Ruth took 1 hour, 1¼ hours to walk home. If we add on to this 1 hour, so you can say 1 like that, half of an hour is 30 minutes, so half of 30 minutes is 15 minutes. Add that all up. 11:20 plus 1 hour is 12:20. 12:20 plus 15 is 12:35 p.m. Don't forget, after 11:59 a.m., it then moves into p.m. Exam question, 2 marks. Here's part of a train timetable, Brighton, London, and the table's there. Graham gets to the station in Brighton, which is up here, at 7:15. So he could get, in theory, the first train. Work out how long it will take the 7:22 train to get to London. How long will it take to get from 7:22 to 9 o'clock? And notice there's 2 marks, so I need to show my working. If I do 7:22, how many minutes does it take me to get to the next hour? So remember, 60 minutes in an hour. It takes me 38 minutes to the next hour, and you can work that out. 22 plus 8 is 30, and then 30 plus 30 is 1 hour. Plus another hour. How long does it take for the train to get to London? It takes 1 hour, and we can write it down like this: 1 hour and 38 minutes. You can either abbreviate or you can write it out in full. Next topic is rounding. Let's think about 3.567. If I wanted to round to 2 decimal places, I go from the decimal place 1, 2. Think about your second number. Is the next number 5 or above? So the 7 is 5 or above. Therefore, I need to round up. My answer here would be 3.57. And notice what we're doing here is decimal place. We're writing this as 2 numbers after the decimal. So the answer is 3.57. Similar thing with significant figures. So if I take 3.567 again, if I do it to 2 significant figures include any numbers before the decimal, whereas decimal places only include numbers after the decimal. Before the decimal, the 3 is significant, the 5 is significant, and any numbers after that is also significant. 2 numbers, 3 and the 5. The 6 is the next number. Is 6 5 or above? Yes, it is. So my final answer is 3.6. I've got 2 numbers here, whereas above, for decimal places, we had 2 numbers after the decimal. Let's have a go at the question. 4.27, correct to 1 decimal place. This is the first number, this is the second number. Second number 5 or above? Yes, it is. So I need to round to 4.3. Next, 248, rounding to the nearest 100. So that's my hundreds place value. Is the next number 5 or above? No, it's not. So this number is closer to 200. 6.1282, correct to 3 dp. So 1 number, 2 number, 3 numbers after the decimal. Is the next number 5 or above? No, it's not. So my answer is 6.128, 1 mark. 9,271 to the nearest 1,000. This is thousands. Is that 5 or above? So that's the next place value. No, it's not. So my number is closer to 9,000. 9999, correct to 1 significant figure. Is the next number 5 or above? Yes, it is. So I need to round up, but I can't round the 9 up without going to 10. So my answer here actually is 10,000. 120.196, correct to 2SF. This is my first place. This is my second significant figure. Is the third significant figure 5 or above? No, it's not. Final answer is 120. Notice for these questions, I can't write 12 because 12 is not at all close to 120.196. Although the 0, if it's before a number, is not significant, here we still have to include a 0 to get close to a good estimate to what the number would have been. So when we round, we still add a 0 at the end if we need to. Next, 1923.34, correct to one significant figure. This is my first significant figure. The next is my second significant figure. Is the second significant figure 5 or above? Yes, it is. So round up. That goes up to 2000. Next, 0.1532, correct to two significant figures. The 0 is not significant here. So we've got 1 is my first, 5 is the second. The next significant figure, 5 or above? No, it's not. So I get 0.15. And hopefully you're getting the pattern with these types of questions. Write this number to the nearest million. Let's write commas, make it a bit easy for us. So this number is 2.9 million. This is our millions, this is our hundreds of thousands. So is the 9 5 or above? Yes, it is. So this number is closer to 3 million. Next question, which is an exam question, 1 mark from a foundation paper. Write 7.26451 to 3 decimal places. So this is the first number after the decimal, second, and then the third. 7.265. And you can always check this. 3 decimal places means you want 3 numbers after the decimal, which we have. 56.78, correct to one significant figure. This is my first significant figure. Is the next one 5 or above? Yes, it is. Round that to 60. 478 to the nearest 100. Again, exam question. This is 70. Is that 5 or above? Yes, it is. So this number is closer to 500. Simplifying and ordering fractions. Let's say you've got 1 over 3. That's the same as 0.33333 recurring. 1 over 4, 0.25. 1 over 5, 0.2. Missed out a half. Half is 0.5. 1 over 10, 0.1, etc. These ones are the ones that you need to know. Just to remind yourselves, anything divided by 0 is no solution in maths. Sometimes people get a bit confused with this one. If you've got 1 cake and you want to share it between no people, how many cakes does each person get? Well, if there's no people, you can't share out a cake. It doesn't make any sense. In this scenario, we get no solution always. Write 18 over 90 as a fraction in its simplest form. 18 over 90. Simplify what number goes into both. 9 goes into both. How many 9s into 18? Twice. How many 9s into 90? 10. We can simplify further. How many 2s into 2? Once. How many 2s into 10? 5 times. Final answer, 1 over 5. Just to recap, we're thinking of all the numbers which go into both the top number and the bottom number. The biggest number I can think of is actually 18. How many 18s go into 18? Goes once. How many 18s go into 90? Goes 5 times, which gets us back to our 1 over 5 answer. 1 over 4 is a decimal, we covered. This is one to remember, 0.25. 1 over 5 as a decimal, as we mentioned, 0.2. Make sure you remember these. 14 over 63. What number is common in both? 7 is common. When I do my 7 times tables, it goes into 14 and 63. 7 into 14 goes twice, so 7, 14. If I do my 7 times tables, how many times does it go into 63? It goes 9 times. Can I simplify any further? I can't. My final answer is 2 over 9. 1 mark. 1 over 10 is a decimal. 1 to remember, it's 0.1. Anything divided by 0, we said was no solution. So if this ever comes up, which generally doesn't come up much, but if it does come up, your answer here is no solution. Here is a list of fractions. One of these fractions is not equivalent to 1 over 5. Write down this fraction. So let's go from left to right. 2 over 10. If I divide top and bottom by 2, that's the same as 1 over 5. So it's not that one. 10 over 50. divide by 10 top and bottom, that's 1 over 5. 14 over 70, divide top and bottom by 7, so that goes twice, that goes 10 times. You can simplify further, divide top and bottom by 2, we get back to 1 over 5. 6 over 30, what's common in both is 6, that goes once, that goes 5 times, 1 over 5. Therefore, I know my answer should be 12 over 80, but let's try it. What's common in both? 4. So how many 4s into 12? That goes 3 times. How many 4s into 80? 20. Final answer is 3 over 20, which is not the same as 1 over 5. Write down the following fractions in order of size. We've got an exam paper question here from foundation paper, 2 marks. Starting with the smallest fraction. So there's 2 ways to do it. You can either write these down as decimals, which is what I would recommend, or if you're more confident with the fractions, you can write them down straight off the cuff. But because this is 2 marks, you need to show some working out. So the first method here is better. I'd convert them to decimals and then write them in order. 1 over 3 is the same as 0.3 recurring. 3 over 4 is the same as saying 0.75. 1 over 4 is 0.25 times 3 is 0.75. 1 over 4 is 0.25. We'll come back to the 7 over 12 because we need to work that out. 1 over 2 is 0.5. 7 over 12 is the only more difficult one, so let's do that on the right hand side. So the bottom number goes on the outside. How many 12s go into 7? It doesn't go. So how many 12s go into 70? Do your 12 times tables. 12, 24, 36, 48, 60, 72. 72 is too much, which is 6 times. If I go back to 5 times, which is 60, so that'll be 5 times, that was 60, so I had a remainder of 10. How many 12s into 100? Again, do your 12 times tables. I'm going to carry on from 12 times 5 is 60, 72, 84, 96. So that's 8 times, remainder 4. How many 12s into 40? 12, 24, 36. That's 3 times, remainder 4. So you can see, because I see I've got 40 and then I've got 40 again, I'm going to carry on getting the same remainder. So my final answer is 0.583 recurring, because I'll keep on getting this scenario. So let's go back to the question. Let's read it before we write down our answer. Write the following fractions in order of size. Start with the smallest fraction. So we're writing down the final answer as fractions, not as decimals. Be careful here. So which one is the smallest fraction? 0.25 is the smallest, so 1 over 4. The next one is the 0.3333, which is 1 over 3. The next one is 0.5 or half. Next is the 7 over 12. And the final number is 3 over 4. Just double check we've got the same amount of fractions as the question. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Powers and roots. Let's do a recap of what we covered a little bit earlier. Anything to the power of 0 is 1. Anything to the power of 1 is itself. 2 squared is the same as saying 2 times 2. 2 cubed, same as saying 2 times 2 times 2. 2 to the power of 4, same as 2 times 2 times 2 times 2, etc., etc. You get the pattern. And the opposite applies with square roots and cube roots. So let's go through an example. A number times a number gives 16, that's 4. Number times a number gives 25, that's 5. Number times a number gives 36, that's 6. We can go smaller as well. So a number times a number gives 9, that's 3. So these are all square roots. You can also get cube roots as an example. A number times a number times a number gives 27. So that number is actually 3. So 3 times 3 is 9. 9 times 3 is 27. Could do one more. Number times a number times a number is 8. Answer here is 2. 2 times 2 is 4. Times 2 is 8. And you get square roots, you get cube roots, and you can do the same idea with higher powers. So it'd be, if you had a fourth root, it would be a number times a number times a number times a number gives 16. Our answer's here too. So you'll get familiar with these as you get more practice. So 2 cubed, I didn't mention in the previous slide, we've also got something called square numbers and cube numbers. So square numbers are numbers that are squared. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. And the same with cube numbers. So you can do 1 cubed, 2 cubed, 3 cubed, etc., etc. The left-hand section is square numbers, and on the right-hand section we've got cube numbers. Back to the question, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Final answer is 8. 2 to the power of 6. We've got a lot of 2's here, so I need to count how many. Overall we should be having 6. So 1, 2, 3, 4, 5, 6. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. If you're not sure, write it down in steps. Do it all in steps so it's easy to follow. Anything to the power of 0 is 1. So that's a nice, quick, easy one if you remember what to do. Number times a number gives 81. That is 9. Number times a number times a number gives 8. That is 2. And you can always check these. 2 times 2 is 4. Times 2 is 8. Write down a square number. So that's a number that's squared. That is also an even number. Let's try 1 squared. 1 times 1 is 1. That's an odd number. Let's try 2 squared. 2 times 2 is 4. So that works. Write down a square number that is also even. An example of a square number that's even is 4. Another example, we can carry on going. 3 times 3 is 9. That's odd. 4 times 4 is 16. That works. So 16 is also an example of a even square number. And you can see whenever you have even numbers here, you'll end up with an even number as your answer. Because, a very important point actually, if you have an odd number and an odd number, so odd number times an odd number, then gives you an odd number. However, if you have an even times an even, you'll always have an even number. And you can try this out, you can try different examples. 2 times 4, even times even, that is 8, which is an even number. Let's try odd and odd, so 1 times 9, that's 9, that's an odd number. So it does work, you can try more examples if you want to. Here is a list of numbers, so quite a few numbers here. From the list, write down all the numbers that are powers of 3. 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, 3 to the power of 4, 27 times 3 is 81. So which numbers match the numbers on my list? 9 matches and 27 matches. This is from an exam paper, paper 3, Foundation, of June 2019, question 4. So this is definitely a topic that you want to get very comfortable with. Patrick has to work out the exact value of the fourth root of 64. So let's not read the question, let's work this out. It's a number, and I'm going to do it in big X's, times a number, times a number, times a number, gives 64. So let's try 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. That doesn't work. I'm trying to get to 64. Let's try 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I know my number is actually not going to be a whole number. It's going to be between 2 and 3, because 2 times 2 times 2 times 2 we said was 16, and 3 to the power of 4 is 81. So let's go back to the question. Patrick says a quarter of 64 is 16. 64 to the power of 1 over 4 is 16. Explain what is wrong with what Patrick says. So Patrick has misunderstood what a fourth root is. What we're trying to do is a number times a number times a number times a number gives 64. And he has just worked out what is a quarter of 64. He's not done what we've done over here, which is our main calculation. So to get this 1 mark, you need to make sure you absolutely understand what the question's asking you to do. It's asking you to explain, and the key word here is explain. So remember in that question we did earlier, there's the word difference. And difference means minus in maths. Explain here means you need to explain something. You need to write down something in words. So explain what is wrong with what Patrick says. Patrick hasn't understood what fourth root is, and then you'd explain what a fourth root actually is. That would give you the mark that you're looking for. Factors, multiples and primes. So let's begin with prime numbers. Prime numbers are numbers which don't go into any other numbers when you do the multiples. So the first prime number is 2. So you need to remember 1 is not a prime number. The next number is 3. If I do 4, 4 doesn't work because if I do 2 times 2, if I do 2 times tables, I get to 4. 5 is the next one. 6 I can't do. If I do 3 times tables, 3, 6, I get 6, so that doesn't work. 7 does work. 8 doesn't work. 9 doesn't work because 3 times 3, if you do 3 times tables, you get to 9. 10 doesn't work, 5 times tables. 11, and I'll give you 13, and the list carries on. So these are prime numbers. Factors and multiples. Multiples are when you think of times tables. So if you've got 7, 7 times tables is 7, 14, 21, 28, 35, etc. So when we think of multiples of 7, we think of 7 times tables, or the numbers. When I do 7 times something, what do I get? Factors is the opposite. Factors, if I've got 63, I think of what can I break down 63 into? I can break it down into a 9, and I can break it down into a 7. 7 I can't break down anymore because it's prime. So 9 I can break down into 3 times 3, and both of those are prime. So I've got all the way down to the main factors of 63. Another way to write that is look at the numbers in circles. I've got 3 times itself twice, or 3 times 3 times 7. So that's another way of breaking down a number into its individual either prime numbers or looking at it as a factor. So let's move on to a few questions. Question 1. Write down the first even multiple of 7. Let's do the times tables of 7. 7 times 2 is 14. Straight away, that's my answer. That's the first even when I do my 7 times tables. Write down a multiple of 13 that is between 30 and 40. 13 times tables, 13, 26, 39, 52. So between 30 and 40, that's going to be this one. If you're not sure or you're not too confident with doing multiplication or times tables that are bigger than 12, what I do is I add 10 and then I add 3. That's a good way of doing it. 13 plus 10 is 23, plus 3 is 26. Add 10, add 3, add 10, add 3. That's a good way of doing it. Write down a multiple of 4 that is between 90 and 95. So I'm not going to do my 4 times tables all the way up to there because this is quite a lot further on. So if I do 4 times 10, I get 40. 4 times 2 is 80. I can carry on from this. So 84, 88, 92, 96, 100. So back to the question. Multiple of 4 that is between 90 and 95. It's 92. Write down a prime number between 25 and 30. So let's work through it. 25, that's not prime because 5 times 5 is 25. 26, again you can divide that by 2, do the 2 times tables. 27, that goes into the 3 times tables, so that doesn't work. 28 doesn't work because that's even, goes into 2's. 29. 29 works because no number, when you do something times something, you don't get 29, so it is a prime number between 25 and 30. Write down 2 factors of 28. So let's break down 28. I can break that down by 2 and 14. I only circle the numbers once I get all the way down to our prime numbers. The easy way to do it is just keep on going by 2. If you can't do any more 2's, then try and do 3's. But here I got to 7, so I can't break this down any further. Write down 2 factors of 28. So another way of writing 28 is 2 squared times 7. That way I'm not missing anything, I've got full marks for that. Another way to think about the question is, if you split up 28, what's all the different ways you're splitting it up? So you could do 1 times 28, could do 2 times 14, could do 4 times 7, and any other combinations you can think of if there are any more. Write down all the factors of 16. So what's the different ways of breaking down 16? 16 times 1, 8 times 2. Notice I'm just dividing the first number by 2 each time. 4 times 4. If I divide the first number by 2, I get back to this scenario. 8 times 2 is the same as 2 times 8, so that's not a separate factor. I think these are all the factors that we get of 16. Write down a prime number between 0 and 20, so that's easy. 1's not prime, so I would go straight to 2. Exam paper question. Write down a prime number between 20 and 30. So again, start from 20. 20 is not prime. 21 is not prime because that goes into 7s, 22 isn't, 23. 23 works. That is a answer. The other answer is 29, which is an answer from an earlier question. Coordinates. When we have a grid, first thing to do is always label our axis, x-axis and y-axis. Label our coordinates. So we've got 0 in the middle, 1, 2, 3, etc, etc. Same as here, we always put the numbers on the left hand side. Obviously when you're doing this, try and draw your grid a lot more neater than what I'm doing here. -1, -2, etc, etc on all 4 of the quadrants. If I'm looking to plot a coordinate with 2, 1, this means go down the corridor 2 and up the stairs 1. I'd have a point over here. What we do is when we note down a coordinate, we note it down with a cross, and you can label the cross. So let's try the questions. Plot the point with coordinates down the corridor 4, up the stairs -2. So that's over here on our graph, or on our grid rather. That's our point C. Write down the coordinates of the midpoint between A and B. So let's write down what the coordinates of A and coordinates of B are. Coordinates of A, down the corridor 4, up the stairs 5. Coordinate B, down the corridor -5, up the stairs 5. So if you're not sure about that one, starting at 0, we will start at 0, down the corridor -5, because we want to get to there, and then up the stairs 5. So you can count this 1, -1, -2, -3, -4, -5, up the stairs 1, 2, 3, 4, 5. There is a formula to work out the midpoint. So to work out the midpoint between two coordinates is coordinate A, x1 plus x2 all over 2, and y1 plus y2 all over 2. So just to remind you, the first number is the x coordinates. So this is like x1, this is x coordinate, this is x2, this is our y coordinate, so this is y1, this is our y coordinate, which is y2. And these x's and y's relate to these axes here. So let's plug in everything into our formula. x1 plus x2, so 4 plus -5 all over 2, comma, 5 plus 5 all over 2, plus and a minus is a minus, 4 minus 5 is -1 over 2. 5 plus 5 is 10, divided by 2 is 5. Final answer, put it into the coordinates, -1/2, 5. Question 2, plot the coordinates down the corridor 6, up the stairs 4, put cross right there, label it C. Write down the coordinates of the midpoint AB, again same as before, coordinates of A, -4, 0. Coordinates of B is down the corridor 2, up the stairs -6. Let's write down the formula, so midpoint. The more you write it down, the more easier it will be to remember it, because you'll get used to writing down the formula. x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Sub in our coordinates. Just to remind you, this is x1, y1, x2, y2. -4 plus 2 all over 2, comma, 0 plus -6 all over 2. -4 plus 2, think about your number line, we're going to the right hand side, so -2 all over 2. 2 divided by 2 is 1, so -1. Plus and a minus is a minus, 0 minus 6 is -6. 6 divided by 2 is 3, -3. Final answer is -1, -3. You can also sense check your answers, so if we go down the corridor -1, and then down the stairs -1, 2, 3, the midpoint is there. Does that roughly look like the midpoint between A and B? Yes, it does. So we know our answer looks right. What are the coordinates when x equals -7? So down the corridor -7, so -4, -5, -6, -7. Up the stairs, -2. So what are the coordinates when x is -7? So x is -7, y is going to be -2. Write down the coordinates of the midpoint H and G, same as before. Down the corridor -7, up the stairs -2. G, down the corridor 6, up the stairs -6. Write down your formula in full. I'm not going to write it this time. So -7 plus 6 all over 2, -2 minus 6 all over 2. Put them together, -7 plus 6 is -1 over 2. -2 minus 6 is -8, divided by 2 is -4. Add that to your coordinates in the answer area. 2 marks. 1 mark here and another mark there. Write down the coordinates of G, so down the corridor 6, up the stairs, -6. On the grid, mark with a cross the label down the corridor 6, up the stairs -3. I've missed that. Down the corridor 6, up the stairs -3. So that's over there. Try and be as accurate as possible. Label that point I. On the grid, draw the line with equation y equals 7. So when is y always 7? Y is 7 over here, because this is the y-axis, and this is 7. Is y 7 over here? Yes. Y is 7 over here? Yep. Is y 7 over here? Yep. Is y 7 over here? Or let's say over here? No, it's not, because x is 7, but y is actually 0, because remember, y is this line. So when is y 7? Y is 7 anywhere along this line here. So what we need to do is draw a line using a ruler in your exam. Draw a nice line. And you can also label it as well. So y equals 7. So moving on to the next topic, pictograms. Pictograms is another way of displaying data. Let's say you want to represent 6. Another way to write that is 1, 2, 3, 4, 5, 6. So this is using a tally. Another way might be, imagine you get a full circle, but split into 2 bits. Each bit might be 3, right? If I've got 3 plus 3 plus 3, I've then got a total of 9. It's another way of writing data, and you'll see that when we do a question together. Question 1, the tally chart shows information about each time a bug was seen. Do the numbers correctly reflect the tally in the grid? So let's double check. The first one, when we have a cross, we know it's a 5. So 5, 10, 11, that works. Next one, 5, 10, 15, 20, 22, that works. 1, 2, 3, that works. 5 plus 1 is 6, that works. 5 plus 3 is 8, that works. The answer is yes. All the numbers work. And that is what the question was asking. Do the numbers correctly reflect the tally in the grid? Which they do. The pictogram gives information about the number of time a chocolate was eaten. How much chocolate was eaten on Thursday? So Thursday is over here. We've got a key, so let's look at what that says. A full circle represents 3 chocolate bars. So we've got 3, 6, 9, plus 1.5. So 9 plus 1.5. The reason why I'm doing 1.5 is because remember, a full circle represents 3. Half a circle represents 1.5. Final answer is 10.5 times chocolate was eaten. 1 mark. David sells CDs in a shop. The tally chart shows information about the number of CDs David sold Monday, on Tuesday and on Wednesday. Write down one thing that is wrong with the tally chart. So let's check it out. So Monday, 5, 10 plus 3 is 13. So we know straight away that's wrong. This should be 13. And this was an exam paper question. Straight away we would get our full mark just from that. But let's carry on going and see if there's anything else. Tuesday, 5, 10, 15 plus 3 is 18. That's fine. 5 plus 3 is 8. The rest is fine. So the issue that we have is with Monday. So hopefully you've enjoyed the video. This covers all of the topics within grade 1 for GCSE Mathematics, covering both foundation and higher level maths. Hopefully you feel more confident with the basics. If you're not sure about anything, go back and watch the video. Otherwise, leave some comments below and I'll get back to you. Remember that mastering these topics will help you be successful for future grades. As you get into harder topics such as grade 4 and grade 5, these basic fundamental things that you're learning in grade 1 will help you throughout all of your maths. So it's really important that you master all these topics really well. So if you enjoyed the video, come and support us at Pauri.co.uk. We've got more worksheets covering every single topic in GCSE. We've got individual videos showing each topic such as addition and subtraction, BIDMAS, negative numbers, all of the videos, all of the topics we've covered today, and we have live group sessions as well. If you want to reach out to us or look any further, come and visit us at Pauri.co.uk. Otherwise, I'll see you in the next video.